Hi, welcome back to our channel and back to tutorial for computer organization. Today we are going to see about the hazards, the types of hazard and so on, and the structural hazard only you have to see today. And before that, you have to know what is pipelining, because then only you can clearly understand what is hazard. Pipelining is nothing but a technique or method where multiple instructions are overlapped during the execution. And also, the problem generally arises when you deal with the pipeline is called the hazards. Moreover, the hazards may arise in the pipeline also prevent the next instruction from executing during its designated clock cycle. Let's see with a small example. Let's remember. So let's assume that there will be a car factory. There will be four section of car factory with groups. The group one going to chase the spare parts, and the group two going to fix the engine, and group three you have to assemble everything. At last, everything ordered with painting done. At go for delivery here. So this is the scenario of manufacturing company a car. This happen in the process one by one. Let's assume that the scenario where start with the clock cycle of T0 followed by clock pulse of T1 and end with the T7. So if let's just assume that is it possible means it is possible we can manufacture a car and go for deliver at a time. That is a multiple instruction. So let's assume that the when the T1 T0 time started, the one of the group may start the process. That means chase the spare parts and go for engine fitting, at last go for delivery. And same whenever the T1, another car may start to manufacture. That means fix the what you can chase and go for fix the engine and so on and so on. So at last T7 they can complete all the process. That means car 1 execute car 1 manufacturing over and go for checking and deliver. Same then car 2 and car 3 Kia 4. This for understanding purpose. Let's go for the example we know. And today we're going to see what is structure hazard. So structure hazard is nothing but hazard. It happened due to a or occurs due to a resource conflict in the pipeline. So before going this concept, you know what is resource conflict. Resource conflict is a situation when more than one instruction tries to access the same resource in the same cycle. So that means what? You can say some resources, same resource requesting the same, sorry, some resources requesting the same resource. That means the resource may be a register, memory, or ALU. So in the same clock pulse, they're expecting. Let's see the example, we get clear idea. So let's assume that instruction I1 having the having the operation of add R1, R2, R3. Then similarly, I2 have the option of operation of add R4, R5, R6, and I3 have the subtraction operation. Let's go for the example. Understand the scenario, we are going the clock pulse diagram where generally if you go for understanding the pipeline with hazard, especially structural hazard, you know these four things, that is instruction fetch, instruction decode, execution, and write back. So at last result, write the result back here. Let's assume that here we have a you're going to fetch the instruction, that is instruction 1, the clock pulse of 1, and clock pulse of 2 I2 and clock I3. Now we are same after that. Once come to the clock cycle of clock pulse of 2, next instruction decode is that we can try to perform the odd operation. Because instruction 1 is that add R2, R3, save the result in R1. And we can give the chance to the next cycle person can give the chance to R5, R5. That is also addition operation. And next also we are going for this like and when for the execution phase, when the clock pulse, we can allow for the R2 plus R3 is odd operation, and again give the next I1 that is over, then I2 that is odd operation, and I3 that's next we can give a chance for subtract, that is R1 minus R8 here. So once you closely look out, there will be a chance of inconsistency happen here. That means here I3 executed after I only, so inconsistency happen. So how you can avoid the instruction? Because inconsistency, because the R1 is used by different places, okay, different purpose in the same clock cycle. So resource, that means requesting the same resource. So here solution is simple. We can make the delay of the pipeline. How we can make, that means here the I1, I3 is coming I1 only, no? So we can make like this. That means we can delay the pipe and go for the execution. That means once like this, delay the pipe, that what happen? The instruction, first instruction will be executed properly and the result will be saved in the R1 successfully. So here the delay the pipe is called another name called bubbling or pipeline install, or pipeline break. So I hope that you understand there are three types of hazard is there. One is called data hazard, another called handler hazard, another called structural hazard. So I hope that you understand simply what is structural hazard and how it impact the pipeline and we can resolve like that. Thank you for watching the video. Thank you.